Good day, folks. Welcome to Brightsman Academy, where we bring brilliance to every lesson. Now, in today's video, we're going to be looking at carboxylic acid as well as esters, right? Now, we already looked at aldehydes, ketone in the previous video, right? Yes. So now, I'm saying you're going to be looking at carboxylic acid, okay? Yes. This is one of the um, weakest acid, I think. Yeah, one of the weakest acids. But when you deal with acids and base, here it is strong. Now, this is what homologous series. Homologous series. Remember, okay? Now, I'm saying carboxylic acid is a name. So, can you guess its name? Its name is going to be carboxyl. Carboxyl group. Now, remember ketone. Do not confuse this. Ketone, it is carbonyl. Carboxylic acid, it is carboxyl. From carboxylic acid, it is carboxyl. So, yes. Now, let's look at the functional group of carboxylic acid rather. Functional group of carboxylic acid, it is carboxyl. So how can we see that? We're going to see that by saying, oh, okay, it's going to be this. It is double bond OOH. We see it by Q. Normally we say it is what? Q. Here. So this is a carboxyl group. Okay. Functional group, its name not carbonyl, carboxyl or carboxyl group. Okay. Now, we normally say it is RCOOH. Cool. Okay. So the R can either be halogen or a substituent, but you just see it. Or if you do not want to say functional group of this one, it is that you can say it is RCOOH. Okay. Okay. Yes, but it's fine. Let's stick with this one. Okay. Sorry. Yes. All right. And this should be, I think this should be R. Yes, this should be R. Why? Because remember, the minute we put R, we are showing you, oh, okay, so this one should always be on the terminal carbon to be a COOH. Why should it be a terminal carbon? Remember last time when we had something at the terminal carbon, we had a reason because the following one that we were going to do, it was similar to that one, but different, okay? So, okay, us saying this one, this Q should be on the terminal carbon. It means now the one that you're going to do next, it has the same COOH, but now a different place. Oh, okay. So, okay, that's good. But now remember, this should be always, okay, terminal carbon. Terminal carbon. What is terminal carbon, Hannah? Terminal carbon, it is carbon number one. Okay. So now let's look at something like it's what? Oh, it's its general formula. Its general formula will be the same as ketone and aldehyde, but instead what will differ is that instead of only CnH2nO, we'll say 2. Why? Because we have 2 oxygens. Oh, that's the case, yes. Okay, so yes. Then now the suffix, can you guess the suffix? It will be a little bit tricky to guess suffix for this one. Where we go to the name. Can I guess the suffix? Can I say it ends with an carb? It ends with a lic, it ends with a oxy, it ends with a acid, rather it will end with an oic acid. Ic acid, but oic acid. Okay, the ending here will be oic. Something butanoic, oic space acid. Okay, to show you, oh, okay, this is a acid that you're talking about. So it's gonna be what? Oic acid. Okay, yes. So on this one, we do not have many things that are tricky or what. Now let's look at naming. Naming what? Naming carboxylic acid. It is not difficult. We do what? We prioritize the what? The OOH. Okay? The crew. We prioritize the C double bond OH. Okay? No need for numbering. Again, no numbering for the functional group. Remember, if it is on the terminal carbon, there's no need to say it is carboxylic butanoic 1 acid. I don't know how you're going to fill up that in. Why? Because it is always on the first carbon, okay? Now let's have an example. I won't do much. I'll just say, just want to, the naming of this one is not necessarily difficult. It's just a straightforward thing. It's just straightforward, trust me. Longest chain, I start counting from where? From my carboxylic acid. Okay. Then I'll say, oh, okay, what is the longest chain? The longest chain is but. So I'm going to say, oh, the name of this one, it means it should be butan. Instead, I'll add what? Oic, what? Acid. I'm done. Remember the prefix, it is what? Oic acid. I know the longest chain, it is butan, but it is what? Oic acid. Done. Like that, nothing difficult. What if I have something like maybe, let's choose it up. When you thought I was gonna do 3, I'm gonna do 5. Okay. I'm sorry for adding a lot of carbons. That is what the examiner does in an exam, when sets an exam. When he or she feels like it's not enough, he just continues adding. Now let's count. Longest chain, we count from the crew. 1, 2, 3, 4, 5. Why is this carbon so little? Like it's scared. 5, 6. Okay, longest chain, it is 6. But now, can you see we had a what? We have a branch somewhere here, a company of a branch somewhere there. Okay, and that branch, it is methyl, right? So I'm gonna say, okay, first thing first, let's start. What is the longest chain? Longest chain, it is hex. So it's gonna be hexane. Remember, I'm gonna add oic acid, hexanoic acid. But now, before hexanoic acid, it means now there is something that I'm left. Remember what I just named? It is this one. But instead, I have also a branch. So that branch, it is on carbon number 3, and it is a what? It is a methyl. So it's going to be, oh, okay, 3-methyl hexanoic acid. As simple as that. Move on to number 9. Is it number 9? Okay. Where's my B here? Carboxylic acid. Number 9, we look at ester. Ester. Now, an ester, it is a product. Okay. I think I'll just come with a theory afterwards. An ester, for just a fun's sake, an ester, it is an organic compound that is formed when we add, or rather when we react alcohol with carboxylic acid. When we react alcohol with carboxylic acid in the presence of concentrated sulfuric acid as a catalyst, then we produce what? Ester. Okay, in a process called esterification. Okay. Now, let's look at that. This is just homologous series. Okay, there's no name of the functional group for this one. Okay. The name starts from alcohol. Alcohol, the synonym of alcohol, it is hydroxide. The synonym of aldehydes, it is formyl. The synonym of ketone, it is carbonyl. The synonym of carboxylic acid, it is carboxyl. Ester, no. Ester, nope. Now let's look at the functional group of ester. What makes it different from carboxylic acid? Let's look at that. What makes it unique is that we still have COO, okay? C double bond O. But now in this case, the C double bond O that we're going to have is going to be like this. What is this, man? It means now, remember I told you that it is composed of a mixture of what? It is a reaction of an alcohol as well as a carboxylic acid. So this part divided by an O here tells you, okay, on this other side, it can either be an alcohol or a carboxylic acid, and then on the other side, it is what? It is alcohol or a carboxylic acid. In this case, you can see here, it is carboxylic acid. Why? Because carboxylic acid has double bond OOH, but alcohol had only OH. But now we'll see how did we come up with this one. So for an ester, we need an O in the middle, okay? Where R now can be a hydrogen or a just CH3, okay? Yes. So now, the general formula, it is the same as that of the ester, so of the carboxylic acid. General formula, it is the same as that of the ester, which is CnH2nO2. Let's go here and prove if this is correct now. The CnH2nO2. Let's see. The number of carbons I have here, it is 1, 2, 3, 4. So it is C4. According to formula, it is C4H2nO2, meaning I'm expecting H carbon hydrogens. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Go on. H8. Then I'm expecting O2. 2 carbons. So oxygen's 1, 2 indeed. So it means now it is correct. Okay. Okay. Now this one, there is no difficult naming than this one, or rather the suffix. The suffix of this one is composed of two things. Remember, it comes from what? It comes from alcohol. It also comes from carboxylic acid. So its naming is going to be something alcohol, I, something carboxylic acid, O8. O8. Whereas now this part comes from the alcohol, and now this part comes from the carboxylic acid. So it is going to be something, maybe let's say meth. It's going to be methyl, let's say propanoate. Okay, let's have an example of that. Let's say we have I want you to identify which side comes from the alcohol, which side comes from the carboxylic acid. The one that has double bond OH, sorry, double bond O, it is the one that comes from carboxylic acid. This one comes from carboxylic acid. Then this one, remember, we don't include this O. This one here comes from the alcohol. Okay? This is the side of alcohol. This is the side of carboxylic acid. Remember when I name, if I want to name this one, it's going to be something I, something O8. What is that something? The something is from the alcohol. Remember, I is from the alcohol. Number of carbons here, 1, meaning it is going to be methyl. Methyl. What? Number of carbons in here, it is 1, 2. Here the numbering does not matter as long as you know the number of carbons. Number of carbons from the carboxylic acid, 2. What is 2? Ethan. Ethanoate. Like that. Methyl ethanoate. So it means if I were to write this name correctly, it is going to be something like this. There is a space, okay? The first one, it is methyl. The second one, it is what? Ethanoate. Like that. Okay, ethanoate. There is a space here, okay, to show, okay, this part comes from alcohol, this one comes from uh, uh, carboxylic acid. You can be given this name, and from this name, you need to know how to predict which one comes from an alcohol and what kind of alcohol. From this one, you can see it is meth, and it comes from alcohol. So what kind of alcohol was that? Was methanol. Methane, remember alcohol, it is all. Then this one comes from what? Ethane, but it is carboxylic acid. It is what? Ethanoic acid. So it means methanol, when it reacts with ethanoic acid, it forms what? Methyl ethanoate. Oh, can it? Let's look at the other example. What if in this case now we have something like hmm, something like this. Let's say I have something like this, maybe. Hmm, okay. Now, I need to identify which one comes from the alcohol, which one comes from the carboxylic acid. Remember, I said the one that comes from carboxylic acid is the one that has double bond O. So double bond O, it is here, meaning from there, going there, this is my carboxylic acid. So this side here, it is my carboxylic acid. So I'll just say this is my carboxylic acid. Then it means this one here, it is my alcohol. Now I know when I'm naming, it is going to be from alcohol first, then to what? To carboxylic acid. Now the important part is that me being in a position of saying, okay, let me name what kind of alcohol is this. This, can you see it has 2 carbons? So this is methanol. So 2 carbons, ethanol. Then this one, it has 3 carbons. 1, 2, 3. One thing I used to do in high school, I used to forget this carbon here. I don't know how. But okay, ethanol, this one, it is proper. Remember, it is an acid, propanoic acid. So, okay, when I mix and want to get a full name of an ester, I need to combine ethanol as well as propanoic acid. How? I'm going to say the first one that is going to start it is alcohol, and it will have a suffix of "-ile". So it's going to be ethyl, what? Propanoate, like that, like that. Okay? Like that. Now, I will just automatically do the reaction of ester here. Okay? I'll just automatically do the reaction of ester, what we call now esterification. Okay? What is the esterification? Esterification, it is the process, okay, organic reaction in which an alcohol reacts with an a carboxylic acid to form an ester in the presence of a catalyst, okay, in the presence of sulfuric acid, which is H2SO4, 4 down here, A catalyst. What organic reaction in which alcohol reacts with carboxylic acid? The reaction condition to form a what? To form an ester, in the presence of what? Sulfuric acid as a catalyst. So now let's look at that reaction. Okay. Now I'm saying it is a reaction of alcohol. Now I can say I have an alcohol here. Let me say I have an alcohol, ethanol. Okay. Remember, I'm drawing an alcohol here. Okay. Mm, H2OH. Okay. Plus a carboxylic acid. Let's say, let's keep it simple. Propanoic acid. Propanoic acid. Remember, it has a thing. C double bond OOH. Okay. Propanoic acid, like that. Then let's see the result. Okay. It forms, let's say it forms in the presence of what? In the presence of sulfuric acid as a catalyst. It forms what? I want you to see something. Water is a byproduct on this case. It will do what? It will also form water. Or if I draw it, it will form what? Water. Okay, you can just say H2O or water. Now, where do I take this water? This water, we take what? We take OH from the carboxylic acid, then we take H from the alcohol. This is how we form what? Water. I repeat, you take OH from the carboxylic acid, then you take H from the what? From the alcohol. Then now, what will be left? What will be left here will be H, C, H, but I'm gonna combine them. Okay, so it's gonna be something like this. Check, I'm gonna combine them. I have what? O, then what is it that is left here? C, double bond O, H, H like that, H, H, H like that. Can you see? I just took this one out and formed water, and then the rest I just boom, like I just something like if I were to yo, okay, no, it's fine. If I were to remove this, I'll bring it back. If I remove this, can you see? Can you see? It's like I'm just joining these two. I'm just taking this. I'm just taking this here. Just taking this here and taking it where here and say, voila. Can you see? Can you see? It's still this. It is the same thing. Yes. So this is basically what happens when you remove what? When you remove water. Okay. Yes. So this is what? A byproduct. Product. And it is what? Inorganic. Why am I saying it is inorganic? Because I know the definition of an organic compound. Why? What is an organic compound? I know an organic compound. It is a compound now in which now what? Uh, in which the an organic compound, it is a compound that consists of hydrogen as well as carbon. Sorry. So an organic compound consists of carbon atom. Okay. But this one does not consist of carbon atom. It is inorganic. Remember when I started, I said H2O, it is an example of inorganic. Again, yes, like that, like that, like that. Let me see. Okay, now measures. Um, uh, okay, precautionary measures. What is it that we need to do during the experiment here? During the experiment now, we should what? We should avoid open flames. No open flames. Why are we not, why don't we want open flames? I don't know if flames is written like that or with just an air, one M, I'm not sure. Why? Because now alcohol is highly flammable. Flammable. If you do not like English like me, you can say alcohol catches fire easily. Okay. Another word, it is alcohol is volatile. Alcohol is volatile. Now the question is, what is volatile? What is volatile? So now volatile, not volatile. Volatile means now it it evaporates faster. Okay, it evaporates faster or easily evaporates easily. So those are two measures that you need to know. Okay. Mm. Okay. Now another thing that you need to know is that when during experiments, okay, during experiments, what can you say? Let me say during experiment, okay, the results, the results, the results that you'll get is that okay, during an experiment forming an ester, you will have what? The first one, maybe you will have a very pleasant smell, okay, or a decent smell. I'm not sure if decent is written like decent. Mhm. Let me just confirm how is decent written, okay? Decent, okay, yes. Decent smell. Actually, it is decent, like C only. Decent. Not this one, decent. Let me rewrite that. It's fine. Okay. I can't. Okay. I just stick with pleasant smell, decent smell, but importantly, fruity smell, such as maybe an example, banana. Okay. Yes. It has also aroma. Okay. Aroma. Of. Okay. Something like that. In case you haven't done an experiment for that one, it has an aroma smell. Okay. If you know an aroma, it is something that they use there at home. That it is something like this. I don't know, it is closed. Then they put like stickers in it. Then I don't know. We also have an aroma spray. Okay. It just makes the smell to be pleasant thereof. Yes. So yes, that's all from us for now. The reaction of esterification, right? Now let's look at the last reaction, which now we call combustion. Okay. Now this one is just a straightforward reaction, combustion. Combustion, it is now the reaction of what? The reaction, okay, organic reaction. You don't need to know the definition. That one, this one. The ones that you need to know is the ones that I did a star on them. the organic reaction in which an alkane, very important, an alkane reacts with excess oxygen to form carbon dioxide and water. What do you mean when you take an alkane? What is an alkane? Remember, an alkane, it is something like that has a general formula of CnH2n plus 2. So it means if I want 5 carbons like that, I'll have 10 plus 2, 12. So it means it will be an example like this. C, this one, they like it in terms of molecular formula, okay? Let's say we have C5H12 plus O2 forming now CO2 plus water. You already have 2 marks by doing this, but now the important part is you being in a position of being able to balance this. How do I balance this? I say, okay, I have 5 carbons here. How many carbons? The last thing that you want to balance it is oxygen. You end with oxygen when balancing. 5 carbons, 5. I need 5 carbons here, okay? Then hydrogen, 12. On this case, there are 6 of them. Okay? So now, when I count, it's going to be 5 multiplied by 1. It is 5 carbon, okay? 6 multiplied by 2, it is 12 hydrogen balancing. Okay? Then what happened to this? Now, when I count my oxygen is going to be 5 multiplied by 2, which is 10. Then 6 multiplied by 1, it is 6. Then how many do I have? I have oxygen 16. In this case, I have 2. So I'm going to say 16 divided by 2, it is just 8. Okay? What if you do not have a nice number? Let's say we have, I want a number that's not nice, man. Okay. C7H14 plus, remember it's going to always react with O2 to form what? The important part is going to form carbon dioxide plus H2O. You already have 1 mark for this one, 1 mark for that side, then another mark if it is balanced. Okay, if it is balanced. Then here, let's see, how many carbons do we have? 7. 7, so we need 7 in here because we have 7 in there. Then hydrogen, we have 14 on there, we have 2, we need 7 so that we can say 7 times 2, it is 14. Then let's count the number of oxygen. 7 times 2, it is 14, plus 7 times 1, it is 7. Here. Then 14 plus 7, 21, right? So we have oxygens that are 21. So 21 divided by 2, it is how much? It is 21 divided by 2. But now, when you say 21 divided by 2 multiplied by 2, it's going to be 21. But now remember, when balancing, we do not want fractions. So instead, you're going to be multiplying by what? By the denominator here. So you're going to multiply everything here by 2 to remove a fraction. This one. So if you do that, it's going to be what? Check. It's going to be 2 C7H14 plus 21 O2 forming now for me. Remember, I multiply everything by 2. I multiply everything by 2. Everything by 2. Then 7 multiplied by 2. 7 multiplied by 2, I have 14 what? CO2 plus 7 times 2, 14 H2O. Like that. Like that. Can you see that? So that is exactly what you mean when you say we are balancing the equation. This one is not the final answer. The final answer is the one with a whole number. Okay. So yes, thank you very much, folks. That's all for nomenclature. Fortunately for us, we are done for nomenclature. We'll just look at isomers in the next video. Okay. We'll just look at isomers, then we are done. Okay. Yes. Thank you very much. Follow up with me.